Hello, today I'm going to talk about Neptune in this Neptune lecture. And we've talked about a lot of the other planets, so we're going to get to the last planet in the solar system, Neptune. And one of the most striking things that we see about Neptune is this blue color. So Neptune is the farthest planet from the sun. And Neptune has a blue appearance for the same reason as our Earth's sky. So without getting into too much detail, it has to do with light being scattered and that blue light being the one that we predominantly see. That's why the sky is blue. That's also why we get this blue color from Neptune. It's that blue light being scattered. We've already seen some of the gas giants that had quite a bit of swirling storms, clouds, and noticeable weather. And Neptune is similar. It's not as dramatic as Jupiter, but it has much more cloud cover that we can see and visualize than Uranus. So unlike Uranus, visible white clouds can be seen in Neptune's atmosphere. That's what all these streaks, these white streaks are, big long lines of clouds. The reason for this, and it's the same reason that we see stuff, especially with Jupiter, but also with Saturn, this is because Neptune has more internal heat. So it's this heat inside the planet that causes this rising heat, which then separates out some of the layers, causes different pressure systems, and you get more of this mixing of the atmosphere. All right. In this image, we see some of the storms that will appear periodically on Neptune. Neptune has huge storms in its atmosphere, like Jupiter, although not as many or as clear as Jupiter. But they are present. We've seen them each time we've flown by Jupiter or Neptune. These storms appear as dark spots. So you see these dark blue spots that make up these storms. This is an artist's representation of some of the clouds in Neptune. So this is not an actual shot from a satellite or anything like that. Using the clouds of Neptune, scientists have determined that Neptune has the fastest winds in the solar system at 1,200 miles per hour. So these streaks of clouds that we saw, we can use them to gauge how fast the winds are going, and faster than any other planet, Neptune has at 1,200 miles per hour. Very, very fast, going across the atmosphere. All right, now looking at one of the moons of Neptune. Neptune has several moons, but Triton is the most interesting here. Triton is the largest moon of Neptune. It is geologically active and has a relatively low cratered surface. So because it's geologically active and we're getting new material on it, old craters get covered up. So a low cratered surface. We don't see a bunch of craters that have built up like on the moon. The moon builds up with craters because it doesn't have any kind of geologic activity. But the most interesting thing about Triton, which makes it unique among all the moons in the solar system, Triton is the only moon in the solar system with a retrograde orbit. So if you look at this image, what you'll see is you got Neptune here, and spinning in the same direction as Neptune are all these other moons. They're going counterclockwise, okay? That's the same as the way that Neptune is spinning. But Triton out here, which is, first of all, it's pretty far out, it's going the opposite direction. That opposite direction, that's the retrograde orbit. That's what retrograde means. It's going opposite. There's no other moon in the solar system that does this. And then you can't tell in this image, but it also has an orbit that's tilted on the side compared to the elliptical of Neptune. Very unusual. This suggests that it was a dwarf planet captured by Neptune's gravity. So at some point, Triton formed all on its own, probably out in the Kuiper Belt, and then eventually came close to the gravitational pull of Neptune and got pulled into orbit around Neptune. That's what all the evidence suggests. So very unusual. All right, I hope this helps.